Welcome back to the Land Tamer stream this afternoon. We are back on the grind. I was just saying how lucky I was that I had not yet been called since 4:22 a.m. this morning, and I got a call. So you can't tell, but we'll try. It was nothing. It was just a misfire on an alert. But here we are. We're back, and hopefully we're going to give this a shot. Two things. One, I'm trying these glasses. I've been watching Casey Neistat, and that's what he does, and he explained why. He's got a real cool video about it and why he does it on his vlog, so giving it a shot. I got the brightness all the way turned up, and this may actually help on the stream. So we're giving that a shot, and we have a new wallpaper, which is a tribute to Twin Peaks: The Return. If you've seen Twin Peaks: The Return and are caught up, then you know what this is, and that's our theme for the day. Moving right along, we've got Ospf route filtering, quite a few different methods, and as I talked about before on a previous stream, there's a lot of differences, considerable number of differences in how you do route filtering in Ospf versus a protocol like EIGRP. So in our link state protocol, we have to have within our area, we have to all agree, all our routers have to agree on the Ospf database and the link states in the graph for our area. If there's any disagreement on what that tree is, what the graph is, we're going to have routing loops, we're going to have problems. With that being said, that really changes, of course, where we can filter or summarize routes or summarize the graph or abbreviate the graph in any way. So it's very important that we understand, right? And when I say we, I'm talking to myself, right? And anyone who may or may not watch this video. And by me explaining, this is me using, this is me learning by explaining. So don't feel like I'm, if you're watching this video, that I'm telling you things that you probably already know. But anyway, we have to be real careful about where, there are a lot of rules about where we can filter and how we can filter. And we're going to see in one of these that, this is true somewhat of EIGRP as well, but when we start to do summarization, we can, to prevent loops, we're going to have these discard routes. What do we do with them? How do they impact? So that's what we're going to play with. And I should have the tools I need to do these labs. I've watched all, I think I've watched all the INE videos for Ospf. I've read all the configuration guides that I could find on filtering techniques for Ospf v2. So, but I'm probably going to have to do some more research as we go through the labs. First one, distribute list. So distribute lists are to, let's see, we have a filter list and a distribute list functionality of Ospf. And the distribute lists are for routes, are for LSAs. So we can control, if I have this right, and let me, before I misspeak, let me go into the configuration guide and just review this, because as I'm talking, I'm thinking, wow, I read these yesterday at the mall and understood them then when I read them. However, a lot of this merits revisiting. Okay, so this is a good article. Ospf ABR Type 3 LSA filtering, because like we said, when we're talking about the graph within an area, obviously that's cluing us in that really any filtering we're going to do is going to have to be, it can't just be to any router in an Ospf domain or area. It has to be ABR, ASBR in most cases, right? Or it can be filtering on any router that is running Ospf. I can do filtering of what is going to go into my local RIB or global RIB on that router, locally significant only. But that can have severe consequences, as I think we're going to see in this lab. So this was a good article. Configure Ospf ABR Type 3 LSA filtering. Okay, this is the filter list, not the distribute list. Right. Okay. Yeah, the filter list is what is going to allow us to filter LSAs coming in and out. We did some of this in a lab yesterday, I believe, or Friday. Yeah, that's the filter list. So yeah, we did that yesterday. Now there is a distribute list, and I believe there's an article in this as well. Here we go. All right, so yeah, filter list is filtering prefixes, in and out of an area. Distribute list, with a lot of restrictions. Distribute list is filtering them going into my routing table or my rib, and subsequently into the fib. So that's what we're going to play with today. In this lab, routers 5, 8, and 10, we're going to use distribute list filtering so that router 1 and router 2's loopbacks are not installed in the routing table. So we don't want them at all. What are the implications of this? Let's look at our map. So let's make this smaller here. All right, so we're talking about area 0 and area 3 because router 5 is an ABR of area 0 and area 3. And we want to filter router 1 and router 2's using distribute lists, because we could, since those would be incoming into area 3 from area 0, we could filter those using a filter list on router 5 to prevent those coming in. But that's not the technique it wants us to use here. It wants those to come in anyway. Why would you do that? Okay. Maybe I'm planning to add some routers into this area. And I want them to install those loopbacks into their routing table. Maybe have a test area, and I'm going to have a section A in area 3 and a section B. New routers are going to go in section B. But on these routers in section A, I do not want them, for whatever reason, to be able to reach router 1 and 2's loopbacks. But these I do. Maybe I'm going to be doing some tunneling here, and I want to demonstrate in section B how the tunneling works, and I want to demonstrate in section A how it won't work when the loopbacks aren't reachable. I don't know. That's at least one use case I can think of. But again, this would be a rare use case, I think. So let's think about this. In order to use this feature, let's go ahead and get him back where he was. Over on this screen. And let's open up our terminals. Liking the Sublime text, by the way. It doesn't look like it's easy to edit the colors. That's okay, I can live with that. All right, so we wanted to use a route map and a distribute list to reference that route map. So let's start with router 5, and let's just verify right now that we have show IP route 150.1.1.1, and I do. And if I do show IP Ospf database, this is going to be coming from area 0. So let's just say show IP Ospf database. We're going to see it in area 0 as an LSA type 1. And we should also see it in area 3 as an LSA, as a summary, right? It gets converted to a summary route, flooded into area 3, which is in my database as well. But I want to remove it. Now the question is, yeah, the LSA should still be advertised, even if it's not reachable on my router. That's my hunch. I know that with a default route, there's special rules. Do those rules apply also to more specific routes? Let's see. I don't think they do. I think it'll still flood the LSAs because this is my use case, right, that I just invented. So let's do a route, or let's do a prefix list. R1, R2, and we'll say sequence 10, permit, and it's going to be 150.1.1.1/32, and sequence 20, permit 2.2 prefix, and we're going to say route map, rmap. Let's give it a more clever name than that. Dlist, deny 10, match IP address, prefix list, R1, R2. That almost looks like a robot name, doesn't it? And then we're going to say route map dlist permit 20. Okay. So that should work for a prefix list and route map. Now let's apply that to the routing protocol. Router Ospf1, distribute list. Now which direction? This is going into, this is basically going into our local routing table. I think that's how that works. Distribute list. Okay, I'm not doing this right. Route map. I didn't really need, well, I need a route map to run multiple statements, right? Because I have a deny and I have a permit. So we're going to say, what is it? Dlist. Filter incoming. Yeah. For the, now this is the thing about the Ospf protocol. As far as I understand, because these are always only really locally significant, we're not going to be affecting any LSAs using a distribute list. It's only taking what is in basically the local rib for this OSPF process and filtering those before they get installed into the routing table, my local routing table. So it's always going to be distribute list and OSPF, as far as I know, inbound. Okay. Let's see if that did the trick. First, let's do show route map. Okay, we have deny sequence 10, and we have a permit. We don't have any matches. I'm not sure that we will at this point. Policy, yeah. Well, I'm not going to see any iterations here. If I was doing policy routing, I might. I keep looking at this maybe kind of like an access list, but I'm not going to see any tickers on here, right? Or any counts. Well, on the prefix list, 2 entries. Interesting. So I can do a show IP prefix list and a particular prefix. I didn't know that. Ah, look at that. We do get hit counts. Check that out. I like that. You know, I don't think I've ever looked at the show command for show IP prefix list in the documentation. Let's look at that real quick. That's kind of neat. That could be a very useful command in certain scenarios. Let's go command reference. You guys, can you tell where I'm looking on the screen? Or does it look like I'm looking at you? That's kind of the purpose of these glasses here. This would be protocol independent command reference, right? And under show, is not here. So where would that be? Let's go under master index. show it says BGP. So this is referenced in the BGP book. Guess it's it's mostly used. Okay. So what are options? Detail, summary. Displays detailed or summarized information about all prefix lists, optional. Displays the entries in a specific prefix list. Displays only the prefix list entry with a specified sequence number. Optional displays all entries specified prefix that uses network address and network. I could have used that. I've had a real world use for that with BGP. Display all entries that are longer. Okay, I've heard about this. I remember reading that somewhere. And then first match. Okay, show IP prefix list detail. So I can get, looks like I can get hit counts just by using the detail command. Oh, here's how you reset the hit count. These are related commands. Okay, let's look at that. Show IP prefix list. We can just do detail here. We only have one. Hey, there we go. I like it. So we're getting hit counts. I don't. It has our sequence numbers. This is cool. Let me run that again. It shows you which is the last one you edited or inserted. This could be helpful when you're troubleshooting something. And then it shows you your configured prefix list, R1, R2, count, or 2. No range entries. These are all like a specific prefix match, right? /32s. There are no range entries. The sequence numbers. Reference count. I'm not sure how many times it's referenced. Hit count and reference count. 1, reference count 2. Does it tell me what that is? No, it doesn't say what the reference count is. Let's Google that real quick. Bust out the Googles. No, not full screen. Prefix list ref count. Yeah, what is the difference between hit count and ref count? Okay, ref count. When a prefix is created, its reference is set to 1, and the last deletion insertion prefix list reference is incremented. Okay, so that's when you create it. If a prefix is referred by a routing process, its reference is incremented by 1. Reference counter is a common concept of iOS. Shows how many objects uses the memory block. Each entry's reference count is more complicated. Some entries refer other entries. This is because prefix entries form a kind of tree data structure. Okay, we won't worry too much about that then. Hopefully it won't be on the exam. I wouldn't think so. But I do like the detail option. That's cool because I'm interested in this hit count. If this was still 0, I think, oh, I did this wrong. Of course, I'm going to do other validation, right? Let's do show IP route 150.1.1.1, not in the table. And I should not have reachability, right? No policy routing in place, so if it's not in the routing table, it's not, you cannot reach it. However, just to illustrate the point that the LSAs still get published, we're probably not going to be able to reach this through router 5 because from router 8 transiting through router 5. First of all, show IP route. It should be in the routing table, and it is. But Lo and behold, unreachable. Now let's do it the other way around. Show run. Actually, I'm going to copy this. Onto router 8. And then router Ospf 1. Distribute list dlist in. And over here, no distribute list. Can I do that? No. I have to do the whole thing. Not configured. Oh, because I put a space. No distribute list dlist in. Show run. Oh. Do show run begin router Ospf. Oh, route map, right. Did that very incorrectly. So router Ospf 1, no distribute list dlist in, and router 5. Okay, so just to prove a point, we have applied the distribute list. We have applied it here on router 8 and not here on router 5. So what we should see is, again, the LSAs are not impacted. Actually, let's look on router 8. First of all, the route is gone. Our distribute list worked, but we will still have a summary link so that other routers can reach it, like router 5. He's still in the area, right? And he has it in a routing table, but the requirement is take it out of all these routers. I didn't mean to do that. Distribute list route map dlist in. Take it out of the routing table. Same on router 10. Oh, that's router 9. I keep doing that. So again, router Ospf 1. Actually, we have to copy, let's copy this. And we're going to copy this prefix list and route map. And then router Ospf 1, distribute list route map dlist in. So now show IP route, not in the table. Okay. That takes care of that lab. That's how the distribute list works. Let's look at the routing table though, because we should see show IP route. Do we see a null route? I don't think so. Not in this case. Or what they would call like a discard route. No, we don't see one in this case. We have contiguous. Well, they're not contiguous, are they? But again, this is filtering just going into our local routing table. Let's do show IP route. Yeah. Same with router 5. Good. Let me check the key and ensure that that is correct. Okay, in this case, what was done in the lab, and this works too, is an access list was used in the key. It's basically access list 1. That would have been easier, I admit. Deny 150.1.1.1, 0.0.0.0, blah, blah, blah. And then access list 1, permit any. Or permit any, because it's standard. That would have worked. And then in your distribute list 1, in. That is easier configuration. Agreed. And the prefix list works as well. So good. Well, that takes care of that lab. Well, I'm getting to where I can actually predict, and this is a good sign, I guess. I'm getting to where I can predict what the lab key is going to show for validation. So that's a good sign. I'm actually learning what validation you should be looking for when doing these labs. And most frequently it is check the Ospf database, show IP Ospf database, understand what's happening. Going on to the next lab, summarization and discard route. So we're back to summarization. And again, well, it says distribute list. Okay, so we're going to do a couple of things. I think the distribute list, what this is doing is this is going to break something, right? Because we're going to be doing summarization here. We're going to summarize a default route, and we're going to summarize all the loopbacks here. And we're going to somehow break this with distribute list filtering, I think, and try to fix it. Yeah. So we're going to see how to break routing with a distribute list, because we're going to essentially damage the tables of router 3, which is here, and router 5. These are critical routers in this topology because router 3 is the ABR for area 2. And that is where 7, what is it we're concerned about? 7 and 9, yeah. So what we're trying to do is we're going to say on router 3 and router 5, we're going to remove the learned routes for these loopbacks. We're going to remove them from our routing table, which is going to affect anything downstream here, right? So that means area 3 is not going to be able to get past router 5 because his routing table is impure, for lack of a better word. Same with anything here coming through router 3 into area 2. Because, area 1 has to learn its routes basically from area 0, router 5. One of these, nope, they're not going to be able to reach it. They all have to go through router 5, the hub. So after we damage router 5 and 3, we will lose reachability to 7 and 9's loopback. How are we going to fix that? With some summarization. Router 7 is going to originate a default route. So we have to send a default route this way from router 7. And then we have to summarize this. We also have to create a summary route on router 3 into area 0. So it's not asking us if router 7 creates a default route, what's going to happen? That will become a type 5, right? That will become an LSA type 5, and it will go throughout the topology. Okay, that should resolve. That alone should resolve the problem, but I think what we're wanting to do is practice. Okay, what's going to happen is we're going to create a summarization route. Here's the kicker. They want us to summarize this. Let's say router 7 advertises a default route into the topology. but maybe router 5 has an ISP here with a default route. So what we need to do is when it hits router 3, we just need to create a more specific summary route. When we do that, though, that is going to create a discard. I think what's going to happen here, this is my expectation, is this will create a discard route to null 0. So that will effectively cancel out this default route. So router 6, when I install this default route, router 6 will be able to reach, well, I don't know because that's, yeah, different area 2 and area 1. With that default route, router 3 will be able to reach router 9's loopback. That will fix router 3, I think. This default route will fix router 3. It does not fix router 5 until we send this summary. So once we send this summary address, that fixes router 5 and everyone else reaching these loopbacks. See, if I only fixed it here, that still does not leave router 3 away to get to these loopbacks that it doesn't know about because it's been removed from the routing table. But the default route puts it back. This is a tricky one. I like it. I like it. This is what I expect here on out with Ospf is some of these more tricky. So let's just take it piece by piece. First, let's clean up. Let's clean up our configuration. And let's go ahead and take, let's take all this out. And we'll say, actually do a new, no. Can I just do no route map? I think I can. Let's try that. And then router Ospf 1. This is actually a good exercise too, learning how to remove a configuration in the most efficient way, right? So router Ospf 1, no distribute list, route map delist in. And I'm pretty sure I have to type this entire command in this case. So let's, just for fun, let's try this. I don't think this is going to work. It did. Okay, so that worked there. And then I'm pretty sure that works. I've done that before. It does. And then router Ospf 1, no distribute list delist. Oh, route map. Yeah, it doesn't like that. Okay, let's do that on 8. Oh, interesting. About to paste a string with tabs. There's my tab. Never seen that before. And router 10. Good to go. So going back to this, we're going to create a distribute list, routers 7 and router 9, so that router 7 and 9 are loopbacks are not installed. So let's do the same thing. This time we're going to use access list 10 deny, and I can just use, well, I'll just do 150.1.7.7. I can do host here though, can I? The key on the last lab was not using the host command. but we're going to try it anyway because we're rebels. And then we do a distribute list, router Ospf1, distribute list. Not completely sure the syntax here. So let's just go ahead and put these in. And router Ospf1, distribute. I think we just put the number for the access list. We do. So show IP route 150.1.7.7 on a table. That should theoretically break. I think that's going to break everybody. Yeah, I think that's going to break everybody. So let's go to router 10 all the way to the other end of the network. Show IP route 150.1.7.7. It is in the table, which we expect. And now if I do ping, unreachable. Okay. So let's do this on router 5 as well, because we like breaking stuff. Okay. I will still have it though in the database, right? I still have it in my routing table on all the other routers except 3 and 5, which happen to be the most critical. So we've done that. Now on router 7, first we're going to fix router 3, right? And on router 7, we're going to create a default route, originate a default route. We do not have a default route. So what we're going to do is default formation originate always. Usually not a good idea, but it's there. We don't have internet access in our topology, so we're not going to break anything here. So now I would expect on router 3, I'm not going to have this route, right? But I don't have this route here. Do I just need time? Show IP route. Why did that not work? Router Ospf1, default information originate always. I'm not a stub. At least I don't think I am. Where's my area type? Yeah, supports area transit capability. Area 2, number of interfaces in the area is 5. Okay. On router 3, I should, even in this area actually, I should have show IP OSPF database. This will be an external type, and I have it. Advertising router 7.7, forwarding address. Okay. This should, oh, it's not going to go on router 7's routing table, right? But what about router 9? Okay, he has it. It's just not on. I'm originating a route from router 7. Does not mean I have the route. That wouldn't make sense. It doesn't recurse, right? But on router 3, I do not have it. Show IP OSPF database. Let's look at the routing table. I don't see any OSPF routes. I have no OSPF routes. Why is that? I should be in 4 different areas. I'll bet my distribute list is wrong. Oh, I know what I did. I know what I did, guys. Show run access list. I don't have a permit. Classic mistake. I need an access list. Yeah, I have 2 denies. 10 permit any. Show access list 10. Boom, there it is. All right. There's a route. All right, so now we have, and I need to do this over here too, don't I? Router 5 is stranded as well. Access list 10 permit any. Hey, at least we found it relatively quickly. Relatively. All right, so we have a OE2 coming from router 7. That is a default route. So now, but I still, yeah, still don't have a loopback 0 route. So now I can do ping 150.1.7.7 and it should be good. Yep, I'm golden. And now if I do 9.9, golden, right? Awesome. So that fixed router 3, but what is going to happen to that default route? Essentially, as I understand, that default route will now propagate throughout the domain, throughout the topology. And it does. What's going to happen, though, is will I be able to reach router 9? Yes. Yeah, I can reach router 9's loopback, which that's great. What they want is to create a summary route here on router 3, which I think is going to effectively cancel out the default route, which, like I said, might be a desired topology in this case. So, and to do a summary route in OSPF, we do the area range command, right? So we want router OSPF1 area ID. Which area is this going to be? It needs to go into area 0. So it's going to be area 0 range 150.1.0.0. 205, no, 20 is going to be 205.224. Going to be 224, right? Okay. So we should now see a summary route, show IP route. Oh, wrong one. See, I doubted myself on that. No area 3. area 0 range. How do we undo that? Router Ospf 1, no area 0 range. We want to say area 0 range 150.1.0.0 to 40.0. Show IP route. Okay, now we have a summary to null 0 here, because that is a discontiguous network, right? It's discontiguous from what networks we know about. So we have to have this null 0 summary route, or discard route, right? But we still have area 3 anyway, or router 3 still has a default route. So theoretically, we'll worry about the other areas, area 0 in a moment. But theoretically, if I do show IP route 150.1.7.7, it says directly connected via null 0, route metrics 1, share count is 1. So yeah, that is a more specific route, isn't it? Router 3 and router 5 can still reach loopbacks of router 7 and router 9. So what we need to do is remove the discard option. And there is an option to do that. Let me see if I can remember. Well, I'm not going to remember what that is. I did read about it in a configuration guide. So I was wondering if we were going to use that in this lab or not. And now I know that we do need it. Okay, that is here. LSA3 filtering. Oh, that's a prefix. What is the discard command? Where did I see that? That was under, was that under here? No, that's prefix suppression. I'm gonna have to Google that. No idea where that is. OSPF no discard. So it sounds like it's just real simple. No discard route. And we have external and internal. This is an ABR scenario, right? So this will be internal. So now let's look at our routing table. Okay, remove the discard route. And I do not have that route myself, do I? The /20. I do not. But I have reachability from here. Now in area 0, there should now be a summary route. show IP route. I do not have it. Let me look back at router 3 and make sure I did this correct. Show run. Area 0 range. Now that's going to originate from area 0, isn't it? I think we need to originate this from area 3. Let's do no router Ospf 1, area 3 range. So is that the from direction? Yeah, that did not do it either. So could it be because I have the no discard that it is no longer show IP Ospf database? And this will be a summary in area 3. Yeah, that doesn't really make sense because it's not going to. I'm in a lot of areas on this thing. All right, I'm gonna have to look at the key before I get way too far ahead of myself. You know what? I think I just had the area wrong. I did. Shoot. Area 2. Why was I saying area 3? He's not even a member of area 3. Okay, that's the issue. All right, I was close. I was very close. I got a little sloppy on this one. I got a little sloppy with the area numbers, and I got a little sloppy with the access list. So we have to be, got to be real careful about that. So let's fix the problem. Show run router Ospf, and I had to Google the command because I did not know the command. Could I have found it? Sure, I could have. Before I fix it, let me just look this up while I'm thinking about it. So if I go to command reference, I already know it's going to be Ospf routing. I could have looked at discard. There it is, discard route. I knew it was called a discard route. To reinstall an external or internal discard that's previously removed, use the discard route command. External and internal discard route entries are installed in routing tables by default. During route summarization, routing loops may occur when data is sent to a non-existing network that appears to be part of the summary, and the routers performing the summarization has a less specific route, discontiguous. To prevent the routing loop, a discard route entry is installed in routing table to ABR or ASBR. That would be external. Yeah. Okay. Yeah, I got a little lazy maybe on that. I'll admit it. So this needs to change because we are not even in area 3. That was the last lab. Router Ospf 1. We need to area 2 range. Okay, so now show IP route. Well, it's not going to be on this router, right? It's going to be downstream, quote unquote downstream. There it is. Boom. Booyah. So now, yep. Good deal. It's a good lab. I enjoyed that one. It was challenging. So we originally, and this is a really funky configuration, right? Probably never see anything, well, never say never. Nothing quite like this in production, but we got a distribute list filtering, we originated default route, always command, we have a summary, we have no discard, and then we have a summary to fix it. You know, maybe you're in a production scenario and you need a quick fix. This would be a quick fix without necessarily making a lot of configuration changes to this. I could see doing that. Okay. How many more we have? Two. Let's roll on. Let's rock. Let me undo this configuration. These look innocent, but I know they're not. Okay, so let's take out I'm going to say router A Ospf, no distribute list 10 in, no access list 10. And router 3, well, let's go back to router 7 before I forget about him. Let's just take this out. And on 3, all this business. Kind of like this idea of, efficiently removing configuration. Practicing that. Okay, so we're going to do router Ospf1. Let's see if this whole thing works. I think it should. Yep. Okay, back to normal. On to the next. This is administrative distance. We did something like this in EIGRP. Router 10 configured administrative so that Vlan 146 routes are not installed. That is these. And so that's a /24. I think all we do here is we're going to use a distribute list as well. And we're going to do a route map, and we're going to match an access list. Let me just type as I go here because I think I know how to do this. Access list 10 deny. That's going to be 15.1.146.0. And then access list 10 permit any. Well, we don't even need. Yeah, this is just for a route map. So route map B146 deny. No, we're going to permit 10. We're going to say match IP address 10 set set is that the metric? No. Metric value for destination, where to import route. Yeah, that's not what, there's a router Ospf1 distance 255 source address. Ah, okay. Was a lot easier than I thought. Think. So this would be 155.1.46.0. Okay. Show IP Ospf. All right, I'm being, you can tell I'm not talking much right now because I'm really concentrated because I'm really unsure of myself. It's been a while. But we should be able to see here some sort of filtering. How about under show IP protocols? Ospf1. Here we go. Distance. Okay, I've gotten to kind of rely on the show IP Ospf, but we can't forget about show IP Ospf protocols. And here we go. Our default distance is 110, but for this route, we have made it 255, so it should be unreachable. So let's just look show IP route. Still in the routing table with a distance of 110. Do we have to clear the process? Because it's at the sort of the routing process level, isn't it? Doesn't appear to be taking effect. Yeah, I don't think that impacted the routing table at all. (110/4) via, yeah. So let's see. Let's look at the command reference, because we must be missing something. It's not apply. It's like it's not applying. distance, Ospf. There's two commands. Interesting. Okay, that's for generic distant route types. We want a specific distance, weight, blah, blah, blah. To find, use the disk command route to remove the disk command. Okay, weight, administrative distance. 255, that's what we said. Name of IP access applied to incoming routing updates. So this would be if we had more than one, right? Use this command. You must be in a user group associated with task group. Administrative 255 means the routing cannot be trusted at all. It should be ignored. If an access list is used, it is applied when a network is being inserted into the routing table. This behavior allows you to filter networks based on the IP prefix supplying the routing information. So it doesn't look like even though we, okay, this could be on a node, right, on interface level. For some reason, it does not take it when I simply do the distance and an IP address. I'll bet if I use an access list, it'll work though, which we created an access list. Show access list 10. Oh, it's got a deny, doesn't it? Show run access list 10. Yeah. In this case, we want to do a permit, right? Access list 10 permit 51.146.0 000.255. Then router Ospf1 distance. Let's say no distance. We'll say distance 255. Source address. It still wants a source address. Is that the router? I seem to recall that I think is a routing source. So in the case of router 10, it's going to be this address, isn't it? And standard access list number is 10. 250. Mask. Right. Okay, did that do it? And if not, if that doesn't do it, we'll look it up. Show IP protocol. And this address, list 10. Show IP route. That's still there. All right, I give up. Administration can be changed on a per prefix and per neighbor basis, right? Like other routing protocols. Yeah, and I was correct. The address field refers to the originator of the prefix into the area. Okay. Not necessarily the neighbor from which you are learning the route, which is how it is in EGRP. And that would, of course, make sense. That would be the difference between EIGRP and Ospf. So where we went wrong is, yeah, I remember this being tricky with EIGRP as well, is here. It's not the neighbor. We want distance 255 from the neighbor 15.1. Who do we learn it from? Well, let's find that first. Show IP OSPF database summary 151.146.0. We learn it from this advertising router. That's who we need to filter it from. Distance 255 0.0.0.0 and access list 10. 151.146.0. Not in the table. That did it. Golden. Okay. What explains that? Is there something that explains that in the documentation? I'm hoping I'll remember that for the exam, but I don't trust. Yeah, I don't know. I'm going to put that on my to-do list here. Distance, usage, and OSPF. Okay. We'll move on to the last one of this section. That takes care of it for sure. That's like a trick question there. All right, so we'll take it back out. And we'll say no access list 10. Good deal. Okay, route map filtering. I need a drink of water for this. This is good, guys. We've been jamming on these labs. Got a lot done today. I'm almost worried about retention at this point. We should be okay though. But let's just jam. Let's not even think about it. All right. So for this lab, we are going to disable Vlan 45. We've done a lot of route map filtering, so I'm not sure. This is probably going to be like a tricky route map thing, but it wants us to disable VLAN 45. So we're going to disable this link in area 0 to router 4. So let's accommodate that. Router 5. Okay, done. Now, we want to configure a route map filter so that traffic from router 5 to VLAN 146 is sent via router 1. Right now, through the tunnel, we probably are preferring, I'm going to assume we're going to prefer router 4 right now because that would be one less, that'd be a lower metric. Let's just see though. Show IP OSPF database summary with 5.101.46.0. Okay, we have 2 LSAs, 3, well, yeah, that's true, we have come from router 1. This is the one we want to prefer. It has a metric of 1. We have it from router 4 with also a metric of 1. And we have it from router 5 with the metric of 1001. Now, this is area 3, that's why. Because it gets translated from a type 2 to a type 3. Well, these are summaries. So I have a summary in area 0. And that's correct because router 4 is ABR, router 1 is ABR. And then router 5 is flooding the summary into area 3. So that's why it's in area 3 as well. We're only concerned here about area 0. And for that, we have 2 LSAs. We want it, however, to prefer to use router 1. Which will it prefer now is a good question. Just by can I predict that just using the So what is my metric? My next question would be, so I have a summary from router 1 and a summary from router 4. I know those are going to be equal. Show IP route. And that's true because we're just, yeah, we have 2. They're equal. We have, if I would have said .1, it'd be different. That I think would prefer router 1. Okay, it's just using the same, right? Okay, so we have 2 equal routes, but we want to prefer the route through router 1, not through router 4. We want to make these unequal. So we don't want to remove the route necessarily. It wants us to use a route map filter. So where can we use a route map? We can use a route map on a distribute list command. That's not going to work. That's just our local routing table. We can use a route map on a filter list, I believe. And the filter list would filter the summary. This has to be on router 5 though, doesn't it? I believe this has to be on router 5. Yeah, configure route map filtering on router 5. So I think what we need to do, if we cannot necessarily filter, can we use a filter list? I think we want to modify an attribute, right? We want to modify an attribute of the route. So we want to set, we could do, no, wouldn't use tags necessarily. What are some of the attributes we can set? Let's go to IP protocol. Is it going to be under Ospf? Maybe. All right, so let's look at inbound filtering using route maps. Yeah, we don't want to use it with a distribute list. I know we did this in ERGRP, we modified the metric. Like we might set the cost, but can we do that on a prefix-based basis? Well, not really, because we only want to influence it on our routing table. Ooh, we could do the administrative distance, couldn't we? We could. We just did that with the poison, called, poisoning the route, making it an AD of 255. We don't want to do that. Why don't we just make it higher? So let's go on to, let's think about this. Yeah, router Ospf 1. First let's do access list 10 permit 155.1.146.0. Then under the router Ospf 1, we want to say distance. Let's make it 120. That should be enough. Now, what is the source? The source will be, we saw that in the LSA, and we have to look in the LSA, right? Because the advertising router is going to be this guy. Zero dot zero dot zero dot zero and access list 10. Boom, that should do it. Let's see. Show IP route. It almost looks like it removed it completely. Access list 10, distance 120. 150.1.4.4, 0.0.0.0. That's not doing what we want, is it? 150. Oh, no, that's not it. 155. See, it changed it for both. It changed the distance to 120 for both. I only want to change it. Let's check and make sure. Did I use this wrong? I thought that was a wildcard mask. That should be 255, shouldn't it? No? Let's see. Distance. Let's take this out. Let's say distance 120. Source IP address 150.1.4.4. Wildcard 0.0.0.0. Well, first let's see if it's back. It's back to a distance of 110. I could change the neighbor statement, couldn't I? IP route, yeah. Distance 255. No, distance 130. Let's say 111. Source address is, and let's look back at our LSA, just make sure I had this right. .150.1.4.4. Show IP route. 5.1.146.0. Yeah, it sets it 111 for both. Maybe this is due to the fact that it is on a tunnel? Okay, I've got one other trick up my sleeve before I look at the key here. Let's just leave that distance alone. And let's go to interface tunnel 0, IP OSPF network point to multipoint. These neighbors will go down. This is probably not the right answer. IP OSPF network point to point. Still, if it is, I'll be proud that I figured out a way, an alternate way of doing this, accomplishing the same thing. Did not want to do that. Router 2. Router 3. And router 4. Then on router 5, we have to do our neighbor statements. And this is where we can do a higher cost, right? Cost. Let's do 2,000. Okay, it says they're full already. Can that be? Show IP OSPF interface. Cost 1,000. 4 neighbors. Show IP OSPF neighbor. State is full. Does it show a cost though? A separate cost. Detail. Don't think it does. All right, let's look. Before I look at the routing table, well, let's go and look at the routing table. Now it prefers. Oh, here we go. We have to reconverge, right? Clear IP OSPF process. Could not use configured neighbor. Invalid option. Oh, I'm using the wrong address, right? I need to use the show IP interface brief. Yeah, the tunnel interface. Ping or 5.1. Oh, that's a loopback, right? Router OSPF1. Do show run neighbor. Okay, I already had the neighbor statements in there. Okay, let's clean this up. don't remember what the network types were before, but let's just say no, no. And let's change the network type back. Interface tunnel 0, no IP OSPF network type. Interface tunnel 0, no IP OSPF network. Should be point to multipoint. Oh, it needs to be point to multipoint. Interface tunnel 0, OSPF network, point, multipoint. Like these labs, they are challenging. Okay, now we need to change router OSPF1, neighbor 50.1.0.4, right? I really screwed this up before to get to this point. That's okay, we learned. Cost. Okay. Clear IP OSPF process. It's just for grins. Okay, cannot use configured neighbor. Cost or database filter is required. Dead time. It says it's adjacent. And it has a different cost. Okay, so let's see. Show IP route. Well, let's do show IP OSPF database first. Okay, this metric is still going to be 1. However, if we say, what did I do? Show IP OSPF database router, he has a link to me of a much higher metric, right? Well, it says metric 1,000. Metric 1,000. in my database, my networks, okay, 2000. That's where we see the higher metric from my point of view. So, show IP route. Moment of truth. Boom, worked. But if this went down, we'd still have a route via router 4. See, the route metric is 1001. Let's take the tunnel interface down on router 1. And I'll bet the metric is 2001. Wait for convergence here. Especially tunnel interface, this is going to take a minute. Being 150.1.1.1. Yeah. Okay, give it a minute. Is it still adjacent? Show IP Ospf neighbor. Well, it's taking a long time to. Yeah, he's isolated. Okay, I got tired of waiting for the H out. Not in the table. There we go. And it's 2001, just like I said. Awesome. No shut. So let this converge, and then the routing table should change. Yeah, it did. Whew, we got through it. That was tough. And this should have been the clue, right? I just did 80 filtering. Did I use a route map, though? Did I use a route map? I did not. I'll bet we can set the cost of the route map. We're not done. Not done here, folks. Router OSPF1. Actually do show run. Router OSPF1. No neighbor 15104, cost 2000. Incompatible OSPF type on tunnel 0. Well, it complains, but then it brings it up. I'm going to reload router 2. No. Let's see what it's configured as when it comes up. In the meantime, we need to We can still use the distribute list, can't we? Route map. Okay, access list 10, permit 151.146.0. Conditional. Okay. This is starting to ring a bell. 0.0.0.255. Route map is a conditional route map. 10. Permit 10. Match IP address 10. Set metric. Add 1000. Then router OSPF1 distribute list route map B146, right? In. So that will change it in my routing table. Should just change the cost of that route in my routing table. Show run interface tunnel 0. Point to multi-point non-broadcast. That's where I went wrong. Okay. We're gonna fix a lot of stuff here. Okay, now our neighborships are back to where they were. So I had it set to broadcast. Ugh, that doesn't work right. Which means I have to elect a wait a second. Yeah. Means I have to elect a designated router. Oh, that's ugly. What I just did was ugly. Yeah. It sort of worked. Okay, so now we got the route map applied. Now let's do show route map. Okay, we got our set clause. Show access list 10. 8 matches. Show IP route. It's a moment of truth. It's still equal. This is supposed to add 1000 to the metric. It's not working. All right, let's take a look at the key here. Match IP next hop. Okay, we did something like this. So here's the down low. What we needed to do: access list 3, permit, access list 4, permit. That's going to be the next hop. So one, I had an incorrect assumption that somehow I'd read into this requirement that we didn't want to completely eliminate the route. A lot of these labs, the validation is you take down an interface, you can still route out the alternate route. There's got to be a way to do what I was doing. Maybe that'll be in a later lab, but for now we'll leave it there. But this is going to effectively eliminate the route using a route map. Instead of a distribute list, well, we're still using a distribute list, but we're using it with a route map. Because we have 2 routes. We don't want to eliminate both of them, just one of them coming from a particular router. So this is what we're going to do: route map deny V146 to R from R4. Deny 10 match IP address 3 match next IP next hop 4. Then deny V146 R4 permit 20. Router Ospf 1 distribute list route map deny V146 R4 in. And that would do it. So let's go ahead and do that. Always forget about the next hop. So it completely removed it. We removed it another way as well, but the requirement was use a route map. So that is how you do it, folks. I should keep a list of labs I had trouble with, but this would definitely be one of them. All right, that is going to end this session. It's getting close to dinner time, and not sure if I'll get another one in. I've got a lot to absorb. I want to go back and look at these labs in detail, the key, especially these last 2 or 3, and do a little study, post-lab study on those, and may or may not come back to the next labs, which are, there's still a lot. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 more labs, so, and good ones. But we're doing well on Ospf. If you enjoy these videos, please like this one or subscribe to the channel, and come join us anytime in the chat. Thanks for tuning in. You have a great rest of your weekend.